Hello everyone, in this video we are going to discuss about a research paper on modified Kaiser cipher for better security enhancement. So we are covering the contents like introduction, cryptography introduction, and then asymmetric encryption, related works, proposed algorithm, experimental results, and finally the conclusion. In cryptography, Kaiser cipher is one of the most widely known encryption algorithms and also it also performs decryption. Then Kaiser cipher is a type of substitution type cipher. In this kind of cipher, each letter in the plain text is replaced by a letter some fixed number of positions down the alphabet. So, in the given plain text, each alphabet will be replaced with any other alphabets according to the number of positions fixed by us or any algorithm which we have chosen. So the data is converted into a non-readable form at the sender side and converted to that data in the readable form again at the receiver side. The symmetric encryption. In symmetrical key cryptography, the key is generated by the encryption algorithm and then sent to the receiver section and takes place the decryption. So, encryption algorithm will generate the key through which we can decode the plain text, and this is sent to the receiver section and the decryption will take place there. So what are the challenges that faced by this encryption? We'll see that the key should be transmitted over the secure channel from the sender to the receiver. So the key has to be transferred very securely without any leaking or it should not be known by any hackers and all. So the channel noise causes harm to the key and the data during the transmission. If there is any noise in the channel through which the key is passing, so it will affect the key that has to be transmitted, and it will also affect the final result, that encryption and decryption process. Asymmetric encryption. It is also known as public key cryptography. It uses two keys. One is public key and the private key. So the public key will be known for everyone. It's public and it is used for encryption purpose. And the private key, which is only known to the user of that key only. And it is intended for the decryption purpose. So in asymmetric encryption, techniques are almost 1,000 times slower than the symmetric encryption processes because this asymmetric encryption needs a more computational processing power. So the Kaiser cipher uses a modulo 26 arithmetic for the encryption key that is greater than 26. This means that for encryption purpose, it is considering all the alphabets, that's 26 alphabets. You can see the formula here. Consider the formula for the encryption, and where x is the value of the plain text, n is the number of shift. X will be the value of that plain text what we get, and then will be the number of shift, how many times we are shifting that uh, alphabets. The most pressing weakness of this cipher is simplicity of its encryption and decryption algorithms. So the related works, few people and the authors or the content writers have dedicated for this paper's content. So the person called Srikanta Swami have proposed a method to include the Kaiser cipher with a random number generation technique for the key generation operations. Then Goyal has described cloud computing security issues. Security is the biggest challenge for cloud computing currently. Obviously, putting everything into a single box, that is to the cloud, will only make it easier for hackers. In this paper, author discuss security issues like confidentiality, web security, and email security. Marston have proposed an algorithm for data encryption and decryption. This algorithm is based on ASCII values of the characters in the plain text. So each alphabet will have some ASCII values. So they are talking about that, and this algorithm is used to encrypt data using ASCII values with that data to be encrypted. Singh have proposed a method of Kaiser cipher substitution and reinforced transposition techniques. Proposed algorithm. So modified Kaiser cipher algorithm. The encryption key is an integer value and it determines the alphabet to be used for substitution. It is based on modulo 26 arithmetic to ensure that the integer value wraps around in case the encryption key supplied is more than 26. Decryption follows reverse operations performed during the process of encryption. So decryption is the reverse of the encryption. So it requires a decryption key and an encrypted text as an input. So encrypted text and the key will be an input for the decryption process. So the decryption key should be complemented to the encryption key so that the reverse character substitution can be achieved. Encryption algorithm. So in the first step, we take the plain text as the input, and second, after that, that is in second text, first alphabet index is checked. If the alphabet index is even, then it will increase the value by 1, else decrease the value by 1. And this and at the last we will get the encrypted text. So the decryption algorithm also has the three steps. We take the ciphertext as an input. So we'll insert that ciphertext. Then check the alphabet index. If the alphabet index is even, then we increase the value by 1. Else it will decrease the value by 1. So at the last we'll get the plain text. So here are the three examples for the alphabets. So when the input text will be the alphabet, and the key is also an alphabet, capital letters, and in that also we have for capital letters separately and the small letters separately. And then we also have example of for the numeric values. If the integer or if the input text is a number or an integer, then we have the key also in that form only. We are comparing the existing cases cipher technique and the modified algorithm. So existing technique uses the key as 3 bits where each character is shifted by 3 characters, and it is a type of substitution where cipher in which each letter in the plaintext is replaced by a letter. So simply saying that each letter will be replaced by another letter in the existing technique. In the modified algorithm, it requires a plaintext and an encryption key, and it is based on modulo 26 arithmetic. Here the key size of cases cipher is fixed as only 1. Yeah, we have the key size of the cases cipher is fixed to 1 here. And another thing, alphabet index is checked. If the alphabet index is given, then increase the value by 1, else alphabet index is odd, then it will decrease the value by 1. In this way, this method is better than the existing one. So the results of the experiment conducted are, first we'll see for the encryption. So we are taking the string, that is computer 123 as an input. Now apply the cases cipher to this encryption text. Okay, encrypting plain text, which where the alphabets are shifted by 1. For example, you can see here the plain text computer 123. So each alphabet is shifted by the 1 letter. So for the C, we have D here. After O, we have P here. For M, N, P, O, and for U, P. And for T, we have S, E, F, R, Q, 2, 1, 4, 4, 1, 2, 3. So we get this cipher text because as per the algorithm, the C that is 2 is even. Refer to the table. So they have mentioned a particular table in the paper. According to that, for the C we have the integer value 2 in that table. So where the 2 is even. So since the 2 is even, we have shifted the letter, like shifted the letter by 1, and we have to add 1 as per the algorithm here. We get D as a cipher text of C. The same way O is even, and we get the P as the cipher text for the O. Conclusion and the future work. So this paper presents the modified Kaiser cipher mechanism. It is a substitution cipher. The use of the internet and network is growing rapidly. So there are more requirements to secure our data, which is transmitted through the networks for the different purposes. So to provide security to the network and the data, the encryption methods are used here. So in this paper, this Kaiser cipher technique is used for the security purpose, and it is a unique in its own way. So security provided by this algorithm can be enhanced further more if more than one algorithm is applied to the data. For more and better security than this, we can apply more and more algorithms, more and more techniques to make our data more safer from the hackers. So future work will explore this concept, and the combination of algorithm will be applied over data to set up a more secure environment for data storage and retrieval. Thank you for watching this video. Please do like